So, what is entropy? In simple terms, entropy measures disorder or randomness in a system. When something becomes more disorganized, entropy increases. When something becomes more organized, entropy decreases. But here is the key rule of nature. In an isolated system, entropy always tends to increase. This idea comes from the second law of thermodynamics. Nature always moves from order to disorder. Let's understand this with an example. Imagine dropping a drop of ink into water. At first, the ink is concentrated in one place, but over time it spreads everywhere. It never gathers back into the drop again. Why? Because spreading increases entropy. Nature prefers states with more possible arrangements. Let's see entropy in everyday life. Entropy isn't just a physics concept, it happens everywhere around us. A hot cup of tea slowly cools down. Heat flows from hot to cold, never the opposite. Ice cube melt in warm water, but warm water never form ice on its own. Perfume spread throughout a room, but it never gathers back into the bottle. All these processes happen because they increases entropy. The universe naturally moves towards more probable states. Disorder simply has more possible configurations than order. Entropy and energy. Entropy is deeply connected to energy flow. Energy naturally spread out. Think of heat again. If you place a hot object next to a cold object, heat flows until both reach the same temperature. This state is called thermal equilibrium. At equilibrium, entropy is maximized. In other words, energy becomes evenly distributed. This is why no machine can ever be 100% efficient. Some energy always spreads as useless heat. Entropy guarantees that perfect efficiency is possible. Entropy and the universe. Entropy doesn't only affect small system, it governs the entire universe. Scientists believe that the universe began in an extremely low entropy state during the Big Bang. Since then, entropy has been constantly increasing. Stars burn their fuel, galaxies evolve. Energy spreads through space over billions of years. The universe is slowly moving toward a state called heat death. In this future state, all stars will burn out. Temperature everywhere will become equal. No useful energy will remain. Everything will reach maximum entropy. The universe will become silent, dark, and still. But here is something fascinating. Life seems to do the opposite of entropy. Living organisms create order. Cell organize molecules. Plant converts sunlight into structured energy. Humans build cities, technology, and knowledge. So, does life break the law of entropy? No. Living systems maintain order by increasing entropy elsewhere. For example, your body releases heat into an environment. So overall, the total entropy of the universe still increases. Life simply creates local pockets of order. Entropy is more than just a physics concept. It explains why ice melt, star die, energy spreads, and why time itself seems to move forward. Some physicists even call entropy the arrow of time because without entropy, there would be no direction of time. From the smallest atom to the entire cosmos, entropy quietly shaped the destiny of everything. The universe began with order and it is slowly drifting toward chaos.